In this video, we're going to be talking about authentication and authorization. Let's first define those two words. Authentication basically means the process of authenticating user, implying ensuring that the user is who the user pretends to be. This is typically implemented by giving each user an individual username and a password. Now, hopefully, unless somebody is managing to actually hack that password, that means every single time somebody logs into your system with that particular username and password combination, you can with a reasonable certainty guarantee that the user is who the user claims to be. That is authentication. Authorization implies that you authorize a specific user to perform some tasks in your system, basically ensuring that the user is legally allowed to do some task or not. This is typically implemented using RBAC, role-based access control. And this is what we mean when we in Magic go into management and we choose users and roles. You will see here we have a user. This user has a password. Then we have a bunch of roles here. Now, each user might belong to one or more roles. So there's a one-to-many relationship between a user and a role. And multiple users might also belong to the same role. So the way this looks like, if you open up SQL Studio and you choose your Magic database and you go down here and you see roles here, and then you see users, there's no direct reference between roles and users, but we're actually having a link table where we have the role in the user's roles here, and then we have the user pointing to the users over here. So if I click this guy, you will see it points to the users table. If I click this guy, you will see it points to the roles table. This allows us to apply a many-to-many relationship in SQL. Now, how is authentication and authorization implemented in Magic? Well, in order to understand that, I'm going to have to give you another acronym, which is JWT. Now, if you go to jwt.io, this is the primary website to understand JWT. JWT, again, is an acronym, and it means JSON Web Tokens. Now, it's basically typically implemented, or it's always implemented, as JSON, obviously. However, it's actually not one JSON payload, but it's actually three JSON payloads. You see that JSON payloads are base 64 encoded, and this first part up until the dot, that is the header. Second part from the dot to the next part, that is the payload. And the third part at the bottom here is the signature. And the signature is implemented by using the hashing algorithm from the header and then the type declaration here to generate a cryptographically secured signature, which implies that unless you have access to the secret, assuming it's a symmetric hashing algorithm, then it becomes impossible for anybody to reproduce that token unless they're able to somehow read it. Assuming you're over an HTTPS connection, SSL or TLS, it basically becomes impossible to create a valid JSON token. Why? Because when you attach that JSON token, let me show the process here by clicking F12, choosing network, and then I refresh here, and then you will see any one of my AJAX requests, such as, for instance, let's find system information here. You will see now in the headers that it's actually attaching as the authorization HTTP header, a bearer token, that's what Magic uses internally, containing my particular JSON payload. Now, this thing you want to be very, very careful with and not share with anybody. The only reasons why I can do it is because the expiration time of my JWT token is 120 minutes into the future, and I'm not going to publish this video before 120 minutes have passed, implying if you copy and paste this token and try to use it as, while you're executing HTTP endpoints towards my cloudlet, it's not going to work because the token is going to be expired. That is another crucial feature of JWT tokens. They expire. Now, even though you could, even if you saw it before 2 hours passes, it doesn't really matter because I'm going to destroy this cloudlet after the course is over anyway. So it doesn't really matter. So I can even show you my Jwt secrets. Now, my auth secret here, as you can see here in the auth sections of my configuration parts of my Magic Cloudlet, is basically just randomly generated gibberish. And you can provide anything you want to here. Actually, if you want, you can change it to blah, 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 if you want to. The point about this is that my payload, when a JWT token is generated, has this value concatenated to it, and then a cryptographically secured hash is generated, which basically becomes my JWT signature. So this results in that unless somebody knows the exact characters in my secret, then creating a valid JWT token without being able to steal one is actually theoretically impossible according to everything we know about cryptography, because hashing, cryptographic hashes, is a one-way thing. So now that we know the theory about it, we know the theory about JWT tokens, we know the theory about authorization, we know the theory about authentication, we know the basics of RBAC, role-based access control systems. Let's actually see how Magic is using this by creating an HTTP endpoint that we secure, ensuring that only users belonging to one particular role are legally allowed to invoke it. Click HyperID, click Modules, click Tutorials, and create one new file here, active folder, new file, and name your file tutorial 03. Let me see, tutorial 03. tutorial03.get.hl, and click carriage return. Now this of course creates a Hyperlambda file. First we can apply some commenting if we wish. Example of how to secure your API endpoint using JWT and the internals of Hyperlambda's JWT token slots. Now, if we go below here and we click function, we write auth dot, and then we click control space, we will see every single slot that is related to authentication and authorization. Auth is kind of like a common shortened name and implies both authorization and authentication. Here you see we have ticket create, we have get, we have enroll, and we have refresh, and we have verify. The most important one that you're probably going to be using on a daily basis is the last one, auth.ticket.verify. We now click carriage return, write comma, and then we write root, comma, admin, and then we just below this part we write return, carriage return, tab, result, colon, hello world from a secure endpoint, and then we save the file and we invoke the file by clicking F5. And you see everything is kosher now as we're invoking the endpoint. Why? Because the HTTP Magic dashboard, let's invoke it again. Dashboard is actually automatically attaching the JWT token for us. It's a part of the HTTP header as it is invoking our get URL here. However, if we copy this invocation URL, we open up an incognito window, we paste in the URL and click carriage return, we are going to get access denied. Why? Because this HTTP request does not have a JWT token. If we now look at everything here and we look at the get, the URL is the same, the verb is the same, but there is no authorization HTTP header here the way we had it when we invoked it from the dashboard. This is just like a convenience feature let me see, tutorial 3. Request. This is just like a convenient feature that Magic Dashboard applies for you automatically, such that you should more easily be allowed to debug your endpoint. Now, what's actually happening here is that this thing here will throw an exception. And in fact, let me write a comment above. Throws an exception unless user belongs to root or admin role, right? Now, here you can see this is basically a comma separated list. We have root, comma, admin. If we want to give access to, for instance, guest users to invoke this endpoint, that's very simple, comma, guest, we save it, and now guest users can invoke the endpoint. If we want everybody to be able to invoke the endpoint, we just delete it. Now everybody. And now if I save it and I click F5 and I copy the invocation URL and I open up an incognito window, everything is kosher. I'm getting a result from the endpoint saying hello world from a secure endpoint. However, now obviously my endpoint isn't secure, so if you click Control Sets, then you're going to be able to secure it again, and you can remove the guest role and click Alt S to save the file. Now, if you want to, you can actually implement your own authentication process, because if you remember when we wrote auth dot and then we click Control Space, you see there's actually an auth.ticket.create thing here. This allows us to actually create our own JWT tokens. And in fact, let's do that just for fun. Comment away this line of code, and then we do auth.ticket.create, and then let's do username, howdy, roles.foo.bar, save the thing, and then let's return :x @ auth.ticket.create. Let's attach an HTTP header to it such that we get the correct content type, text / plain, save the thing, F5, invoke it, and now you can see we're having, well, the front end doesn't actually that great. Let's change it to return result or ticket for that matter. And then unwrap :x plus / save, and then let's invoke it again. And as you can see, let me see. Let's remove this guy, save, and invoke. And here you can see we're now getting a JSON payload of JWT token. And we can copy this token, go to jwt.io. We can paste in the token here. Be careful with these tokens for the record if you are in a production system. And as you can see here, username is howdy, belongs to the roles of foo and bar. Look here. That's exactly what we said. Username howdy and roles foo, bar. Now let's just delete this code such that we have the original code, save the file, and then we have the original authentication code. However, I just wanted to illustrate how you can create your own authentication mechanism if you wish. And in fact, if you open up system files here, which you should be very careful with for the record, be very careful so you don't save stuff here. You look at auth and then you look at authenticate get, then it's actually invoking a slot further down here that invokes auth.authenticate and dynamically created a slot the way we saw a couple of videos ago. That's named magic.auth.authenticate. And it's passing in the username and it's passing in the password, and then it's returning the result of this thing. So this is the process that actually creates our JWT token, and we can create our own authentication mechanisms if we want to, where you take care of your own roles and blah, 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 and you can invoke third-party HTTP endpoints. Maybe you have like an SSO module already installed on your system that accepts username and passwords and returns JWT tokens or whatever. And it's very easy to bridge from Magic and Hyperlambda into any existing SSO module. That's basically what I want to illustrate here. So now let's look at how this is implemented at the database layer. Why? Because there's a couple of crucial points here related to security. Now, if you open up SQL Studio, and we see our Magic database here, and we select all from users. Let's do that. Select all from users. Function F5 or F5 on Windows, and we will see our usernames and passwords being returned. Now, do you see the way the password is stored here? This is the second line here, this thing here, right? Now, this is a blowfish-based hash with a per record individual salt. That is why it starts out with $, and has a dot in here, and then has the actual hashing of the password. If you have a software system that does not store password in this exact, more or less, structure, your security is probably garbage. And the reasons why is because if I zoom out now and let's say I take my database and let me find my database. Let me first close this guy. I do a backup of my database, export, not DDL, but download backup. and I upload this to, you know, somewhere on my network, and somebody magically manages to hack my network, then unless I'm using per record based individual salts and slow hashing, then doing what is commonly referred to as a rainbow dictionary attack becomes ridiculously simple. So they can basically reverse engineer every single password in your system quite easily. So that is point one. Point two is if we go to HyperID and we show system files here, be yet again very careful with editing stuff here, and we look at the authentication slot, you will see that it actually does not have a validator for passwords. There is no place in here that it asks for special character, number, capital character, small letter character, and blah, 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 blah. And the reasons why is because that's basically rubbish. In fact, the guy who invented this regular expression-based password creation logic himself explicitly regrets inventing it. He said it was the worst thing he ever did to the software development industry during his entire career. Why? Because people end up creating passwords that looks like FGH7 at $. This is 1, 2, 3, 4, 5, 6. Let's add 2 more characters, 1A. Do you know how many minutes it takes for a modern computer to crack this password? 15 minutes to try every single possible permutation of an 8-letter long password. So if you have passwords that are 8 characters, you have a problem and you should change your password. In fact, they should be at least 15 characters. The problem with these regular based expression password validators is that this is impossible to remember. So you end up writing it down either on a piece of text or storing it in a file on your computer, at which point you might as well tag your password in your local village and hang it up for everybody to see it. So you should never write down passwords. So what is a good password again? Well, actually, this is a very, very, very good password. Exclamation mark, seriously. This is actually a very, very good password. Why? Because the number of words in the English dictionary is roughly 150,000. So this becomes 1 word, 2 words, 3 words, 4, 5, 6, 7, 8, 9 words. Now that becomes 9 to the power of 150,000. This is before we start adding special characters such as exclamation marks, which actually makes sense here, and all caps and slang letters. Maybe some guy is writing "serr" instead. This is a Norwegian slang word that means seriously, for instance. So this is an incredibly much more secure password than this thing here, FG5%4. This password is rubbish. It's meaningless. You might as well not have a password. So now let's have a look at the endpoints menu item, because there's one final thing I want to show you, which is the power of meta programming. You see, if we go to our endpoint here that we created earlier, let me just hide system files and close these guys. Expand modules, tutorials, and you open up our secured endpoint, you will see it invokes auth.ticket.verify with root, admin as the username, as the roles required in order to invoke this endpoint. We now go to endpoints here, and we filter here on tutorial 03. We see that this is the role requirements for a user to be able to invoke this. This is because the endpoint retrieval actually semantically opens up the Hyperlambda, semantically reads it, and is capable of retrieving meta information associated with this particular endpoint. Obviously, the role requirements being some of the more important parts of the metadata information that this particular endpoint happens to be exposing. So this allows you to see easily what authorization requirements your endpoint has. For instance, log.post here has an asterisk. That means you must be authenticated, but anybody who's authenticated can actually invoke it. This gibberish means it doesn't have anything. It means that anybody can invoke it. So this one we can copy full invocation URL to, open an incognito window, and we're actually going to get a result here, right? But if I do the same with an endpoint that has authorization requirements, then what's going to happen is that I'm going to get access denied. And of course, yet again, the way this is implemented at the Hyperlambda level is that this slot actually throws an exception. So I can do anything I want here, io.file.delete, for instance, :x:/ slash, let's do folder, just to, folder delete system, right? I mean, that would be a fairly significantly bad thing to occur if I copy this invocation URL, access denied, my system folder is still here. If I refresh and I show my system files, my system folder is still here. So if I removed, let me remove it so I don't accidentally delete my system folder for the record. Then if I removed this thing here, then anybody can delete my system folder by basically invoking this get HTTP endpoint. So anyways, yet again, there's a link in the description of this YouTube video to an article where you can find a code that we used during the video. Remember to like the video, subscribe, hit the bell, and share the video with your friends. Thank you for watching. Have a nice day.